Okay, so sine rule states that the ratio of A over sine A, meaning this A over sine A, is equals to the ratio of B over sine B, the angle opposite, and this is equals to C over sine C. So these three ratios are always the same, like we have seen in the applet. And of course, right, we can take the reciprocals. So we have sine A over A also, meaning now is the sine of this angle over A instead of A, the length, over sine of the angle. And it applies for all. So the ratios are the same also. So what's very important here is that now over here, right, for both sides, for both of the different, so-called different representations, we are taking the A over sine A, meaning it's the sine of the angle instead of A over angle A. Okay, it applies for everything. And we're going to see how we're going to use this to solve our problem. But one thing to note, right, is that this sine rule applies to any triangle. In the past, we have learned the basic trigonometric ratio. The tangent theta is equals to opposite over adjacent. We have the cosine, we have the sine, and so on. But remember that this thing, these ratios over here, applies only to right angled triangle. Only to right angled triangle. But sine rule is more powerful because this applies to any triangle. So now let's see how we can use the sine rule to solve problems. Okay, so in this question, we have triangle ABC where angle A is equals to 67.6 degree, angle B is 45.5 degree, and AB is 7.6 cm. So we just have to check that all these information here, they are labeled on the diagram. Okay, then we have to find angle C. We have to find this angle over here. So nothing special about this. This is just our usual way of finding angle when we're given the other two angles of a triangle. So just use the angle sum of triangle property to find it. So in this case, angle C is 66.9 degrees. So now let's do our part 2 together. So we have to find the length of BC. We have to find this. So what sine rule states? Let's write it down. So sine rule over here, right? We have A over sine A, so equals to B over sine B equals to C over sine C. Meaning that now I have to identify the angle that's opposite it. So let me write it down. So what I know, right, is that the sine rule states that my BC over sine 67.6 degree. This is equals to some other ratios. Of course, we have two other ratios. We have B over sine B, C over sine C. But in this question, right, because we have 7.6 cm, we have this 66.9 degree, and this forms a pair, meaning that now my BC over sine 67.6 degree can be written to be equals to 7.6 over sine 66.9 degree also. Okay, then you all may say that, hey, actually this is also equals to my AC over sine 45.5 degree. My AC over sine 45.5 degree. Of course, this is also the same. But let me just box this up and ignore this first. I'm going to ignore this first. Let me just continue to solve for BC. So in this case, right, my BC will be equals to 7.6 over sine 66.9 degree. I'm going to bring this over to the other side. So times sine 67.6 degree. So I'm just going to press this into a calculator. 7.6 divided by sine 66.9 times sine 67.6, and I will get 7.64 cm, which is correct to 3SF. Okay, so now let's go back to our box text over here. So we have found the length of BC. But why didn't we use this ratio just now? Because for sine, right, sine rule actually says that all these three ratios are the same. Okay, why didn't we use this, right? Is because we actually don't have AC also. We don't have this. We don't have this value here. So if we're going to put BC over sine 67.6 degree to be equals to AC over sine 45.5 degree, then we're going to end up with two unknowns in the equation, which we can't solve. So in this case, right, we don't use this. It's not wrong, but we don't use this. Okay, so we are going to use the pair that we already know, which is 7.6 over sine 66.9. Okay, and that's how we solve this question.